Implicit differentiation. In this section, I will differentiate a few formulas, few equations using the new method implicit differentiation. This method is telling me that I have to differentiate both sides of the equation with respect to x, and then solving the resulting equation for the derivative of y, dy dx. We have to always remember that function y is the function that depends on x, f of x. We will not explicitly see the formula for y. However, we have to remember y depends on x, and we're looking for dy dx. That means we have a few things that is worth to remember. In order to differentiate x cubed, for example, of course we're using the power rule, and derivative of x cubed is 3x squared. In order to differentiate y cubed, I will also follow a power rule, 3y squared. However, I have to follow a chain rule, and I have to multiply everything by derivative of y, dy dx. I might use the notation 3y squared times y prime. That's the same thing. But we remember that behind y we have a function we can call inner function, and we're multiplying by the derivative of this. This is a chain rule. And maybe one more example. Derivative of x with respect to x, of course, is 1. Derivative with respect to x of y, it's y prime, or if we like dy dx, if we like this notation. Please remember derivative of y, it's y prime. Let's start. Exercise number 1. Differentiate an equation x squared minus xy plus y squared equals to 7. That means I will take both sides of the equation and differentiate with respect to x. X squared minus xy plus y squared, and then I will also differentiate with respect to x the right hand side. Derivative of x squared is 2x. Now derivative of xy, we have to remember we have a product rule. Derivative of x is 1 times y. X times derivative of y, it's y prime. Derivative of y squared is 2y times y prime. We remember chain rule. Derivative of constant 7, 0. 2x minus y minus xy prime plus 2y y prime. We're solving this equation for y prime. I have to isolate these two terms on one side, and I will write the positive one first. 2y y prime minus xy prime, and I will add y to both sides and subtract 2x. Now I will factor out y prime. 2y minus x will stay. Copy this side and divide both sides of the equation by 2y minus x. And this is my final answer. And I think it's this one. Exercise number 2. The same thing, different equation. Differentiate y squared equals to x cubed minus 3xy plus 3 with respect to x. Derivative of the left hand side with respect to x, and the derivative of the right hand side with respect to x. Derivative of y squared is 2y y prime. Derivative of x cubed, 3x squared, minus, and now again we do have a product. Derivative of 3x is 3 times y plus 3x times derivative of y. And derivative of 3 is 0. 2y y prime 3x squared minus 3y minus 3x y prime. We need this quantity and this one on one side, since I'm solving for y prime. 2y y prime plus 3x y prime, and quantity 3x squared minus 3y will stay on this side. Let's factor out y prime. 2y plus 3x will stay in the parentheses, and I have to copy this, and I will divide both sides of the equation by 2y plus 3x. 3x squared was on the right hand side. This is the final answer, and I see this answer in the option B. 3x squared minus 3y, 2y plus 3x. Exercise number 3. The same thing. Let's differentiate using the implicit differentiation x squared y, x, y cube, and with respect to x, the right hand side 8. Both of the terms is product. Please remember to use the product rule. Derivative of x squared is 2x times y, then x squared times derivative of y, minus derivative of x is 1 times y cube plus x times derivative of y cube 3y squared times y prime. Derivative of 8, 0. Let's rewrite 2xy plus x squared y prime, and you probably noticed that's what I did in the 2 previous examples. We have to distribute a negative sign. Negative y cube, negative, and let's make a nice order, negative 3x y squared y prime. I'm solving for the derivative. This means y prime, and y prime is here. I have to keep these terms on one side of the equation. X squared y prime minus 3x y squared y prime equals to, and then I will add y cubed to both sides and subtract 2xy. Let's factor out y prime. X squared minus 3x y squared will stay in the parentheses. I have to copy my right hand side, and I am dividing both sides of the equation by x squared minus 3x y squared, and this is y cube minus 2xy, and I believe this is my final answer. And looking at all of these options, we always have to be really careful. I see my answer in option A. One more thing I could add here, because fortunately my option is the same. Please note that I can switch the order because one numbers are negative, positive. I can put positive 2xy and then negative y cube. This means that I did factor out negative sign. I can also do the same in the denominator. Can put negative in front, 3xy squared minus x squared. Because if I will distribute the negative, this will be negative, this will be positive. That's what is above. Negative and positive. But I will not do this. These two negatives will cancel out, and I might have the equivalent form as a 2xy minus y cube, 3xy squared minus x squared. Just in case if you will get this form, make sure that you can rewrite playing with these negative signs. Exercise number 4. Given the equation x squared plus y squared equals to 2x y squared plus 1, find dy dx, but at the point 2, 1. X is 2, y is 1. It means now I will use implicit differentiation, but I will take the advantage of the given point 2, 1 and use the point right away. Let's differentiate first. I will differentiate with respect to x left hand side, and I will differentiate with respect to x right hand side. Derivative of x squared is 2x. Derivative of y squared is 2y, y prime. Derivative of 2x y squared, product. Remember to apply the product. Derivative of 2x is 2 times y squared plus 2x. Derivative of y squared is 2y, y prime. Derivative of 1, 0. Okay. And now, since I don't have to get a nice formula, as mentioned before, I'm using my points. X is 2, y is 1. I'm taking the advantage and substituting them right away. Might use different color. 2 and 1. Let's see. 2 times 2. 2 times 1. Y prime. 2 and then y is 1. I can possibly do 2 and 1. Let's see if I can. 2 times 1 plus 2 times 2 times 2 times 1 and y prime. And we don't have to put plus 0. Okay, that's me. Let's see what we have. We have 4 plus 2y squared, 2 plus 2 times 2 times 2 times 1, 8 y prime. Probably you can do this step right away, but I wanted to show you that I'm substituting instead of x and y the given point. And then subtracting 8y prime from both sides, I have negative 6y prime, and subtracting 4 from both sides, I have negative 2. Dividing by negative 6, I am getting my derivative as a 1/3, and this is derivative at the point 2, 1. And that's my answer. That's me. Please take the advantage as I did and use the points immediately. The point immediately. Okay? Almost the same thing, but a little bit of application. Find an equation of the tangent line to the curve xy plus x plus y squared equals to 11 at the point 1, 2. This means we know that the equation of the tangent line needs a slope. That means I can possibly write point slope form. Point slope form of the equation of the tangent line. The point is given, y minus 2, and this is slope, dy dx. Slope means the derivative at the given point, x minus 1. This means the only thing that I have to do, I have to compute dy dx at the point 1, 2. Let's differentiate using implicit differentiation both sides of this equation. xy plus x plus y squared, and then derivative with respect to x of the right hand side. Again, I see product, remember to apply. Derivative of x is 1 times y, x times derivative of y. Now we have inner function x plus y to the power of 2. Derivative is 2 times the quantity x plus y times derivative of the inner function, derivative of x, 1 plus derivative of y, y prime. Derivative of 11 of the constant 11 is 0. And the same thing, I'm gonna take the advantage of my point 1, 2, and I will substitute to my equation. 1 times y, this is just y, and y is 2. I'm switching the colors. 1 is, we have to substitute for x, and then y prime. 2 times x plus y, 1 plus y prime equals to 0. And x plus y is simply 1 plus 2. Let's see what we have. 2 plus y prime. 1 plus 2, the blue numbers, is 3. 3 times 2 is 6. And I will distribute 6. 6 times 1 is 6. 6 times y prime is 6y prime. 6y prime and 1y prime is 7y prime. And subtracting 8 from both sides, I have negative 8. Dividing by 7, the slope is negative 8 over 7. Slope of the tangent line. Tangent line at the point 1, 2. This means now I have to come back, and I know that my slope is negative 8 over 7. That's my equation of the tangent line, but I would like to simplify. Let's make a room here, and let's try y minus 2, and then negative 8 over 7x. Negative 8 over 7 times negative 1, it's positive 8 over 7. That means now we do have negative 8 over 7x, and then 8 over 7 plus 2. Negative 8 over 7x, and this is 8 over 7, and this will be 14 over 2. Negative 8 over 7x plus 14 plus 8, 22. Oh, something is wrong. I'm supposed to put 7, right? And this is correct. 14 over 7 is 2. 7 the common denominator. That means that's the equation of the tangent line, and I see this equation here. You probably notice that the only slope negative 8 over 7 is here. That means I could maybe save time and not using my purple color to get the equation, but I wanted to show you how we can get a y-intercept just in case if the slope will be placed in multiple options. Exercise number 6. The same thing. Find the slope of the tangent line. Actually, this is just the slope of the tangent line for the curve, and this is our curve at the point root 2 1/2. The same thing. Slope of the tangent line is just the derivative at that point. Let's differentiate with respect to x tangent pi y squared, and then differentiate with respect to x squared times y. Left hand side. Derivative of tangent is secant square of the same angle times derivative of that angle. Derivative of pi y squared is pi 2y times y prime. On the right hand side, I see product. Let's use the product rule. Derivative of x squared is 2x times y, and then x squared times derivative of y, y prime. And as always, let's use the advantage. X is square root of 2, y is 1/2. Let's see how we can simplify. Secant square of y is 1/2. Squaring 1/2, I have 1/4. Pi over 4. Okay, I will be a little bit faster this time. Pi times 2 times 1/2, and then y prime. 2 times square root of 2 times 1/2. Squaring x means squaring square root of 2, which will be 2, y prime. Okay, still some simplification. 2 and 2, 2 and 2. What's left? Pi y prime, and then secant at 45 squared. Square root of 2 plus 2 y prime. Pi y prime. We still need a value. Secant at 45 Secant is a reciprocal of cosine. That means if we remember cosine, 1 over square root of 2, secant is just square root of 2 at 45, at pi over 4 squared. Yes, a little bit of unit circle. Root 2 plus 2y prime. That means squaring root 2, we're getting 2 pi y prime. And now I will keep 2 pi y prime and I will subtract, that's not square, I will subtract 2y prime and just leave the square root of 2. Now factoring out y prime, it's leaving 2 pi minus 2 in the parentheses. And now I will divide both sides by 2 pi minus 2. And that was my right hand side. And this is a slope of tangent. Line at the point square root of 2 half. Let's see if we have the option. Square root of 2 over 2 pi minus 2. That's my option. Exercise number 7. Find y prime, f prime, if the equation is equal to sine of x plus y equals to y squared times cosine of x. Okay, that's we're looking for, of course, f prime means y prime or dy dx. Let's differentiate with respect to x sine of x plus y, and let's differentiate with respect to x y squared times cosine of x. Derivative of sine is cosine of the same angle, x plus y, times derivative of that angle, derivative of x, 1, derivative of y, y prime. Now, the same thing, product, derivative of y squared is 2y, y prime, plus times cosine of x, plus y squared, derivative of cosine, negative sine of x. Cosine of x, negative sine of x. And unfortunately, I don't have a point. I have to solve for y prime. I will distribute cosine and I will multiply by this. That's the first thing. That means cosine x plus y times 1 is just cosine x plus y plus y prime times cosine x plus y. And then we have 2y cosine of x y prime minus y squared sine of x. We see that term is containing y prime and this one is containing y prime. Let's have them on one side of the equation. Y prime cosine of x plus y minus 2y cosine of x y prime. And I will keep negative y squared sine of x on this side and I will subtract from both sides cosine of x plus y. Let's factor out y prime, cosine of x plus y minus 2y cosine of x. And copy that side. And now the last step is just to divide both sides of the equation by cosine x plus y minus 2y cosine of x. And this was on my right hand side. Okay. One thing that I can do, just in case, I can factor out negative sign on the top, which both of the terms will become positive. Okay, that means I'm factoring out negative sign. This will become positive, and cosine of x plus y will become positive. And I can take this negative and apply to denominator, which this means that I have to switch the sign. That means I will remove that and I will switch the sign. 2y cosine of x will become positive and cosine of x plus y will become negative. But both of the forms, this one and this one, they are equivalent. Okay? Exercise number 8. Find all points on the curve where the slope of the tangent line is -1. That means we want slope of the tangent line to be -1. dy dx must be -1. Okay, we have to solve this equation, this condition, and find the points. That means first of all, let's differentiate. Derivative with respect to x of x squared times y squared, x times y equals to derivative with respect to x of the right hand side too. Product rule. Derivative of x squared is 2x times y squared plus x squared times derivative of y squared, 2y, y prime. Now another product, derivative of x is 1 times y plus x times derivative of y, 0 on the right. We're looking for that term and this one. This means I will keep 2x squared y, y prime, and x, y prime, and I will subtract y from both sides and subtract 2x, y squared. Let's factor out y prime, 2x squared y plus x, negative y, negative 2x, y squared. Now I will divide both sides of the equation by 2x squared y plus x, and that was my right hand side. I think I can simplify nicely. Let's see what I can do. I can factor out negative y and I will have 1 minus 2xy plus, because negative is outside. Okay, I will just rewrite. And I can factor out x on this side and I will have 2xy plus 1. And I believe that 1 plus 2xy and 2xy plus 1, 1 plus 2xy and 2xy plus 1 is the same thing. I can cancel out. Of course, we have to remember that 2xy plus 1 is not 0, just for the domain, but we can just keep this condition on the side. That means my derivative is negative y over x. And we know that we want the slope, which is this derivative, to be -1. That means I end up with this equation, and we remember the one problem that with the implicit differentiation is that the final answer of the derivative is in terms of x and y. That means I can't really solve for x, I only have a relation between x and y. Simplifying this, or maybe cross-multiplying, I am getting y is equal to x actually. That means all of the points that x is equal to y, I mean not all of the points, because we still have a curve, the points that they actually lie on the curve and have the same x and y coordinates are the points where the tangent line has the slope -1. Okay, that's the slope of tangent. Okay, but let's come back to this. That means, as I said, not all of the points that has the same coordinates. We can look at the options, but unfortunately 1/2, 1/2, -1/2, -1/2, -1, -1. That means all of them are the same, but which one are right? We don't know. But what we have to do, having this one relation, that means this is one relation, we have to find another relation, another equation. We need a system of two equations. And what we will do, we will always use the original equation. It means the original equation is equal to x squared times y squared, x times y equals to 2. Am I correct? Yes. That we can see this is two equations, because if the tangent line is a tangent, it has a common point with the original equation, which means this condition also has to be satisfied by the equation. That means let's substitute instead of y, x. That means I have x squared and x squared. Instead of y, x, 2. Okay? X to the power of 4, x to the power of 2 minus 2 is 0. I think I can try to factor out x squared and x squared. 2 and 1, positive 2, negative 1. If I multiply, I have this. That means I can say x squared minus 1 is 0, or x squared plus 2 is 0. This one, of course, is giving me positive and negative 1, and x squared is never negative. No solution, empty set. But I have 1 and negative 1. That means at the points 1, of course, because x is the same like y, and negative 1, we will have a tangent line with the slope negative 1. This means the option C is the correct option. The only comment that I have, please remember to use the second equation as the original one. Okay. Exercise number 9. Find the second derivative of x squared plus y squared equals to 9. That means first of all, we need to differentiate first time, and then taking the first derivative and differentiating again, we will get a second derivative. Of course, implicit differentiation. Derivative of x squared is 2x, derivative of y squared is 2y, y prime. Derivative of constant 9, 0. And let's solve for y prime, subtracting 2x from both sides and dividing by 2y. That means negative x over y is the first derivative. Now differentiating with respect to x the left hand side, and differentiating with respect to x the right hand side. Derivative of y prime is simply the second derivative. Now we have a quotient rule. Derivative of negative x is negative 1 times y minus negative x times derivative of y, dividing by y squared. Okay, that means let's simplify a little bit. Negative y, positive x and y prime. But what we have to do, we can't have like x, y and y prime. We do know the formula for y prime. Let's substitute. This means negative and negative is positive x, and times derivative of y is negative x over y squared. Let's simplify a little bit. Negative y, negative x squared over y and y squared. Finding a common denominator on the top, I will have negative y squared over y minus x squared over y. And let's factor out negative. Maybe let's wait one more step. Negative y squared minus x squared over y and over y squared. I can drop this denominator down. That means dropping that y in the denominator, I will have y cubed. And I will have negative x squared, negative y squared. Now I can factor out negative x squared plus y squared over y cubed. And we may also notice that x squared plus y squared is the original equation. It's equal to 9. Okay, that means this is simply 9. Final answer is negative 9 over y cube. That means please note that we have two important steps in the second derivative. We will substitute the original one, the first derivative. We will substitute the first derivative, and at the end we will look at the original equation. That's original equation 9. Okay, another exercise. Find the derivative of this equation. This means I will differentiate with respect to x to the power of 4 times y squared, x cubed times y plus 2x times y squared, and then I will differentiate 1 with respect to x, of course. Okay, we have 3 product rules. Derivative of x to the power of 4 is 4x cubed times y squared plus x to the power of 4 times derivative of y squared, 2y, y prime. Okay, done. Negative, then I have to open parentheses. Derivative of x cubed, 3x squared times y plus x cubed times derivative of y. Derivative of 2x, 2y squared plus 2x times derivative of y squared, 2y, y prime, and 0 on the right hand side. Let's rewrite 4x cubed y squared, 2x to the power of 4y, y prime, negative 3x squared y, negative x cubed y prime. I did distribute negative, important. And then 2y squared, 4xy, y prime. We're looking for y prime, then I have to keep that term, this one, and this one on one side. 2x to the power of 4y, y prime, minus x cubed y prime plus 4xy, y prime. And then I will subtract all of the other terms to the right hand side, subtract from both sides of the equation. But I will start with the negative one, which means I will be adding 3x squared y to both of the equation. I will subtract 4x cubed y squared, and I will subtract 2y squared. Now, just factoring y prime, I have 2x to the power of 4y, x cubed, and then 4xy. And nothing changed on the right hand side. Now I will divide both sides of the equation by 2x to the power of 4y minus x cubed plus 4xy, and I will copy my right hand side of the equation. And this looks like the final answer. This problem is excellent for the practice problem, for the homework assignment, not really the exam type question. But still, we have to be confident with the implicit differentiation. Make sure that you know each step. Exercise number 11. Find the derivative of the curve at the given point. We like the point because we will use this as advantage. We will substitute the values x and y. Okay, that means I will differentiate with respect to x, y times sine of 2x, and I will differentiate with respect to x, x times cosine of 2y. Product rule. Derivative of y, y prime, times sine of 2x plus y. Derivative of sine of 2x is cosine of 2x times 2. Again, product rule. Derivative of x is 1 times cosine of 2y plus x. derivative of cosine of 2y is negative sine of 2y times 2. I can put 2 here. Let's use the points. Okay, that means x value is pi over 2, y value is pi over 4. Let's see. This will be y prime sine of 2 times x. 2 times pi over 2 is just pi. Y is pi over 4. Cosine 2 times x. 2 times pi over 2 is pi. And times 2. Okay, I can leave this one. 1, I will ignore 1. Cosine of 2 times y. 2 times pi over 4 is pi over 2. Plus 2 times x, pi over 2. However, I can put negative because I can put that negative. And then sine of 2 times y, 2 times pi over 4 is pi over 2. Unit circle. This is pi, sine at pi is actually 0. Cosine at pi is negative 1. I can write it down. Let's see what I did. 2 and 4. Okay, I did simplify. And now cosine at pi is negative 1. Cosine at pi over 2 is 0. 2 and 2 is gone. Yeah. And then negative pi and sine at pi over 2, it's actually 1. So what we have? We do have negative pi over 2. Oh, did I lost my... Oh, is something wrong? Of course it is. Too many problems. Because I don't have my y prime. I think I make the mistake here because I was rushing and I was focusing that I don't have enough room. Okay, one more time. This is supposed to be 2y prime. 2y prime. Let me erase this. It will be it will be the same thing. Product rule. Okay, derivative of x is 1 times cosine of 2y plus x. Now, derivative of cosine of 2y, it's negative sine of 2y times derivative of 2y is not 2, is 2y prime. That's what I was missing. It means I supposed to have y prime. I have 2, I have x, but I have to have y prime also. It means we have negative pi y prime. And what we can do, we can simply, maybe I can switch the sides. Actually, negative and negative will give me positive if I will divide. And I can divide both sides by pi. Of course, it's silly. I don't even have to write it down. It means we do have the value y prime, it's 1/2. Which means it's just the slope of the tangent at this point, but they didn't mention. Okay, that means I did one more mistake. Please remember 2y prime. Probably you did notice right away. Okay, that means I have all of my values. Let me just double check. Let me do maybe some pointers. That negative went here. 2 is here. That's the x value. That's my sine of 2y, which is correct. And then y prime. Okay, just double checking for you. And then this is 0. This will be negative pi times 1 times y prime. That's what I messed up. Okay, but you can see how easy we can fix the problem, because you will I realize right away that something is wrong. Okay, another exercise. Let's differentiate. Differentiate with respect to x, x squared plus y squared, And then let's differentiate with respect to x. 2x squared, 2y squared minus x, but everything is squared. And we don't have a point given, that we really have to play with all of these formulas, all of these items. Okay, let's do not make mistake here. Derivative of x squared is 2x. Derivative of y squared, 2y, y prime. Now I have the whole quantity squared. That means let's take care of this one. Quantity squared, like u squared, derivative is 2u. 2, the whole quantity, 2x squared, 2y squared minus x, times derivative of this quantity. Derivative of 2x squared is 4x. Derivative of 2y squared is 4y, y prime. And derivative of x, 1. Okay, I believe at least I can simplify by dividing by 2. This will be gone, and if I will factor out 2, this will be gone. This means I have x plus y, y prime. Now I don't have that 2, but I have to distribute everything. That means let's start. 2x squared times 4x, 8x cubed. 2x squared, because what I'm doing, I can show you maybe this. I'm multiplying the first term by each term. This means I have 8x cubed, 2x squared times 4y, y prime. It will be, I don't need blue. It will be 8x squared y, y prime. Okay, and then 2x squared times negative 1, just negative 2x squared. Okay, now I will distribute this one, and I will multiply by each term. 2y squared times 4x is 8xy squared. 2y squared times 4y, y prime is 8y cubed y prime, and 2y squared times negative 1, just negative 2y squared. And then I will distribute negative x times this, this, and this. Let's start. Negative x times 4x is negative 4x squared. Negative the x times 4y, y prime, negative 4xy, y prime, and negative x times negative 1, positive x. Wow. This term contains y prime. This term contains y prime. This and this. That means all of the blue, the underlined blue terms, we have to put on one side. Let's start. Y prime. And then I will subtract 8y cubed y prime. Let me keep the order first. I will subtract 8x squared y prime. Then I will subtract 8y cubed y prime. And I will add 4xy y prime. Done. What's left? I had 8x cubed minus 2x squared plus 2xy squared minus 2y squared, and then minus 4x squared plus x, and I have also on the left hand side the x that I will subtract, which at least, I don't want to mess up, at least something is cancelled out. And now I will factor out y prime, and I have y minus 8x squared y minus 8y cubed plus 4xy. And let me rewrite for you: 8x cubed minus 2x squared plus 8xy squared minus 2y squared minus 4x squared. Now I will divide both sides of the equation by y minus 8x squared y minus 8y cubed plus 4xy. And that was my right hand side. I'm just copying. Again, this problem is excellent for the practice. You probably will never expect something like that on the test. However, would be nice if you will know each step. And I have the last one. All of the last problems, the challenge one, came from your textbook, and you may try to solve them as a practice. Okay, that's me. Let's do the last one. Let's differentiate with respect to x 2 x squared y squared squared, and let's differentiate with respect to x 25 x squared minus y squared. And actually this question had a point, because this is question 31 from section 2.6, and this we have to find the derivative at the point 3,1. I didn't type this. That means let's use the advantage of the point, because we know how much easier it is. Let's differentiate first. We will copy the constant 2, and now we have x squared plus y squared squared. That means quantity squared derivative is 2 times this quantity, x squared plus y squared. Now times derivative of this quantity. Derivative of x squared is 2x, derivative of y squared is 2y, y prime. Now copy 25, always copy a constant, and differentiate x squared to x and differentiate y squared to y, y prime. Okay, that means at least this one I don't have to play with all of these algebra steps. I mean, I still use the algebra, but I will use the advantage as previously, and I will put for x 3 and for y 1. And let's see what we have. 2 times 2 is 4. This will be 9 plus 1. I did square x and y. And then 2 times 3, 6. 2 times 1 is 2, y prime. Okay. 25. 2 times 3 is 6. 2 times 1 is just 2, and y prime. And 9 plus 1 is 10. Times 4, 40. Okay. And I can possibly distribute 25. 25 times 6 and 25 times 2, negative 2. 25 times 6 is 150. Minus 2 times 25 is 50, y prime. Now we have to distribute on this side 40 times 6, 40 times 2. 40 times 6 is 24 and 0, 240, and 80. Yeah, that's much easier. Let's add 50 y prime to both sides, 130, and let's subtract 240. 130 y prime, and this one is 90, I believe, negative 90. Okay, and now let's divide both sides by 130. I can at least simplify the zeros dividing by. Okay, negative 9 over 13 is the value of the derivative of that curve at the point 3,1. One more time,